Astronomers, we're going to be looking at doing a photometry task with Barnard star. And you've already hopefully watched the video about Barnard star, but it's basically the second closest system to the Sun after the Alpha Centauri system. So Alpha Centauri is in the Southern Cross. Alpha Centauri looks like one star, but if you look at it really, really closely, it's actually these three stars in its solar system, The next closest system, or the next closest star after that, is Barnard star. And you can't see it with the naked eye. It's very, very dim, but you can see it with telescopes. And why it's famous is it looks to be moving up really fast compared to all the other stars. So here's some images from 85, 90, 95, 2000, 2005. And notice how all the other stars in the background don't move. They might get a little bit dimmer or brighter depending on where the photograph was taken. But this one's clearly moving quite quickly compared to those other ones. So we're going to go to a task where we're going to see if we're going to look at a bunch of images and see if we can get a calculation for how fast it's moving. This will take a good hour of time, but it's a good collaboration exercise. All right, so the first thing you need to do here is you watch the video, then you need to download the Barnard star data files from the school's observatory. So if you click on that and open it up, Barnard star, yada yada yada. Here we are here. Here's all the data files we're looking at, all the FITS files. If you just download it as one thing, it'll download faster. So I've got mine downloaded already, and there it is there. So it's a zip file. You need to unzip that or grab everything out of that and save it somewhere else. So the easiest way for me is just to extract all and then put it somewhere. Now I've already put it beside my LT image. I've already extracted it to where I've got my LT image program, the thing we look at stars. So I've extracted it and it's got all my things to look at. I've got my Barnard star data here. The important thing with this is these numbers here are a date. So this is 2005, this image was taken, the 9th month, the 14th day. So 2005, September the 14th. The next one was 2006, 02, February the 17th, 2006, June. And so you got 2005 all the way through to 2011. You got some star photos of, right? So if we go to LT image, the next thing we want to do is we've got our things ready to go. We want to make sure that, we can open one of the images. So file, open. Let's just open the first one. All right. Now it looks like we've got two stars here, but we've just got to change the contrast so we can see more stars. So display scaling. And it's the maximum. We want to see some more things. If I drag this down, you can see up the top here some more stars come into view. Yeah, we'll try that. We'll use these new values. Okay, so everything got brighter. What we're looking for is these three stars here. This one, and this one. And what we have, this is our star chart here, this diagram here. So we have star 1, star 2, and then up on the right is Barnard star. Star 1, this is star 2 here, and that's Barnard star. It's not exactly the same pattern as this because Barnard star moves in each image. But your two brightest stars and one small one nearby is star 2. Now, we didn't see star 2 to start with. When it was like this, we could see star 1, that's Barnard star, but I can't see where star 2 is. So you always got to make sure you're a bit brighter. Okay. We now want to take some distances between these stars and we want to record them in our spreadsheet. So in spreadsheet is record your distance in the spreadsheet. Okay, so we want to measure from star 1 to star 2. So that's the bottom one to the not so bright one. And we want to measure how many pixels that is. Let's go to LT image. First we want to zoom in so we can just do a bit better. So zoom that down the bottom, drag I'm going to zoom again. Oh, drag. Okay, here's my 3 stars. If I go Astro, Size and Distance, then I click in the middle of the star and drag. Drag to my second star. And then up here it says the distance is 128.9 pixels. So between star 1 and star 2, 128.9 pixels. Now I want to look between star 2 and Barnard star. Star 2 and Barnard star. So the really dim one and the top one. So star 2, drag. I'm going to go to the middle of the star, Barnard star. 84.2 pixels. Write that down. 84.2. And now I'm doing star 1 to Barnard star. And that is, back to the picture, star 1 to Barnard star is that. So that's the long axis. We go along here. And there we go. That is 214 pixels. So then I write that one down as well. 214.1 pixels. Now each group, we're going to have 1, 2, and 3 group, will do the same image, and they might get slightly different, but this automatically calculates the average. So we're going to average it out. So we've got a few groups doing it, and averaging it is going to be much more accurate data. Now, what I'll do is I'll post up this this image here. So we've got, this is kind of what we call our finding chart. So we can find everything, star 1, star 2, and Barnard star. But note that they're always going to be in a slightly different place each time. If I zoom out, right. So here they are the bottom left, and they were facing this way. But if I go and open another one, way down here somewhere, yes, and I go, I can't really see anything, so I'm going to do my scaling and change my brightnesses, use new values. Okay, here they are here, the 2 bright ones and the dim one in the middle. So that's, you can see that image again over here. So before they were down the bottom and now they're up here. And then we can look at other ones and that one, display, oh, it's already ready to go. Here it's been rotated. Here's your 2 bright stars and here's your faintly dim one. So here, star 1, the dim one, star 2, Barnard star. Where are we? Here's star 1, here's star 2, and here's Barnard star. You can still go through the same, just zoom in on it. Move it around, it's in the middle. You can still go through the same process as long as you get the distances right. Star 1 to star 2. Now this shouldn't change. Star 1 and star 2 are not moving. So this should always, I've seen, be about 130 pixels. 129.4. Okay? But you'll notice that these distances are getting bigger and bigger and bigger. So this is now up to 254. Right? 254 as our first one started at 84. And then this one is now at 333, whereas it started at 214, so 333. So a couple of things. Make sure you know which image you've opened. Okay? That one, I opened it so quickly I didn't know which one I was looking at, so that's why I'm not going to write down anything here. Make sure you know which image you've opened. You've opened the right image for where you're typing. Compared to the finding chart, they could be zoomed in, zoomed out, not as bright or rotated, but it'll still be a very similar pattern. Okay, so ask your teacher if you get a bit confused using the finding chart to find your star 1, star 2, and Barnard star. Once we've got all our data, this will automatically calculate the average, and then over here it'll give us a graph, and it will give us a calculation. And the thing we're finally looking for is it will automatically calculate the speed, how fast Barnard star is going across the sky. That's what our output that we eventually want to get and check. So good luck, and ask me any questions if you have any.